afternoon, everybody. My name's Carrie O'Neill. I'm a director and senior scientist of the Coral Conservation Program at the Florida Aquarium. I'm going to talk to you a little bit today about our coral spawning program and how we manage the spawning and rearing of corals for reef restoration in the state of Florida. But I'm going to try to touch a little bit on how these techniques can also be used in the hobby and how I think we should be increasing the use of captive spawned corals for availability in the hobby. So a little bit about me. I actually started as a hobbyist. This is my first reef tank back in 1999. Don't look too closely. It's a little bit embarrassing. It's got an under-gravel filter and a hang-on the back protein skimmer. But it did all right, and this really got me into reef keeping. My first job out of undergraduate was as an aquarist at the National Aquarium in Baltimore, where I cared for several large live coral reef displays, as well as a bunch of freshwater tanks. This was one of my favorites. This is a 20,000 gallon Amazon river forest exhibit, so you'll actually see me probably wandering around the conference looking at a lot of freshwater stuff. I do actually really love the Amazon habitats as well. But in 2008, I had the opportunity to go on a coral spawning trip in Puerto Rico with a group called Seacor International. And this really was a pivotal experience for me that has really driven all the decisions that I've made from there on out. So we got to go and watch the elkhorn coral spawn and collect the spawn in the wild and raise these larvae and ultimately return these settled corals back to the reef and bring some of them back to the National Aquarium in Baltimore where I was working at the time. So I brought back about 30,000 tiny little coral larvae in Nalgene bottles and carried them in my carry-on the plane, because you could still do that in 2008. And I settled them at the National Aquarium in Baltimore. And on the right is a picture of some of those newly settled elkhorn coral. Unfortunately, the one there that actually has a little bit of brown color to it means it got its symbiotic algae. That was the only coral of the 5,000 that I settled that ever got its symbiotic algae. And over time, over the course of 4 or 5 months, these little corals that never got their symbionts did actually perish. So none of these corals lived. So that was a really disappointing thing for me. I was so bought into the fact that I was going to settle and raise elkhorn coral and do something great for a species. However, that just motivated me more to continue this through my life, and I actually decided to pick up, move to Florida, go back to graduate school, and worked with what's called a land-based coral nursery at Nova Southeastern University. And a land-based coral nursery is really just an aquarium on land that is used to raise corals for reef restoration. So I worked primarily with Acropora cervicornis, which is the Florida staghorn coral, and grew several thousand of these for reef restoration projects in Fort Lauderdale. And then after working in Fort Lauderdale for a while, I had the opportunity to take this position at the Florida Aquarium Center for Conservation, or our conservation campus. So this is not our public aquarium in downtown Tampa. It's a separate location, and we actually have a sea turtle rehab program and our coral conservation program. Most of our work is done in these greenhouses. Inside of those greenhouses are a bunch of custom designed life support systems, and we're only working with coral that are native to the state of Florida, and we maintain biosecurity procedures so that those corals can be released back out into the wild. Not only our greenhouses, we have a coral spawning laboratory, and this laboratory is based on the systems that Jamie Craggs has developed. A lot of you may know Jamie or have seen his talks at other shows. So we took what Jamie was doing at the time, modified it a little bit, particularly for Florida corals. And these systems control the time of sunrise and sunset, the intensity of the sun over the course of the year, the time of moonrise and moonset, the moon phase or the intensity of the moon, and also the seasonal temperature cycles over the course of the year. And this is all done with equipment from the hobby. We could not be doing this if the hobby had not developed things like the Apex that has the season table in it, which is really our primary thing that we use to program all of this for coral spawning. We do get some coral spawning in our greenhouses because we are in Florida. They do get natural solar and moon cues. And we manually cycle the temperature in those systems in the greenhouses, but they do get some light pollution. So corals are very sensitive to light pollution, especially when you're trying to cue them to spawn. So if there is any light pollution on a time when there's not supposed to be a moon out, those corals can interpret that as the moon actually being out, and that can throw off their entire cycle. So the focus of our program is really trying to make spawning events happen. This is the Atlantic pillar coral. This is the first species we spawned in 2019. This coral is in a lot of trouble in the state of Florida. There's only 24 of them remaining alive on Florida's coral reef. They were lost to a disease called stony coral tissue loss disease, which I'll talk about a little bit more in a minute. And ultimately, our goal is to raise these offspring. And this is actually the hardest part. Getting the corals to spawn is one thing. Raising thousands and thousands of babies in a cost-effective way is the most difficult part. And why does this matter for the hobby? This is great for restoration. We produce 8,000 corals a year right now for release onto Florida's coral reef. But why do we need to be doing this for the hobby? First of all, it's a sustainable way to produce corals. A lot of the corals that we buy in the hobby still are sourced from the wild. Aquacultured corals still drive a pretty high price tag, and unfortunately, even corals that have been somewhat aquacultured or maricultured still are originating from the wild and maybe fragged a few times and sold, but there's still a lot of wild harvests. And a lot of those wild harvests may be closed down. We've seen this happening in some countries. There's more import and export bans. Places like Indonesia are at major risk for potentially shutting down the export of corals entirely. So we really need to think forward about how we are going to produce certain species if wild collections are closed down. It's interesting being in a show with reptiles and freshwater because this is commonplace with reptiles and freshwater to have captive bred animals. We don't have captive bred animals readily available for corals. And there really is a potential for designer corals here. Look at what we've done with clownfish with their breeding. The photo that I added is a designer spliced coral by Jamie Craggs. This is actually two separate Acropora individuals that as they were growing fused together and formed a chimera. So half of it is green and half of it is purple. So through breeding is when we can start to select for certain traits. As you get in later and later generations, you can start really thinking about what might happen with some of these color patterns, and there really is the potential to produce amazing color patterns and corals that we've just never seen before. And it's really important for the hobby to just realize that what you do in this hobby supports research and science. In corals right now, the conditions in our oceans are getting so poor that this last summer in Florida, the bleaching and water temperatures was so bad, the first response was take the corals out of the ocean and put them in an aquarium. And without the knowledge of how to keep corals in aquariums, which has fundamentally come from the hobby, scientists and researchers and people that do coral restoration in Florida would not have been able to pull 10,000, 20,000 corals out of the ocean this past summer, keep them alive on land, wait for the temperature to go back down, and they're just now putting them back out on the reef. So it really is the technology, the knowledge that is driven by people like you that is allowing scientists to really have much stronger intervention with what's happening in our ocean. So how do we do this? And how could you think about doing this for corals for the hobby? There's really 4 steps. First, you got to make the coral spawn. Then you've got to make the larvae. Then you've got to settle the larvae. And then you've got to raise the babies. So we're going to go through these steps one at a time and what that looks like. You have to choose your broodstock. You're going to need multiple adult colonies of the same species. Sometimes this coral might not fertilize that coral. They might be separate male and female. They might be hermaphrodites, male and female together. Every species is a little bit different, so you really want to have a minimum of 5 or 6, if not 10 or 12 is even better, of the same species, and they have to be spawning size. They can't be little pieces. They have to be a mature colony. And then you want to think about what species would be best to choose. Probably not something that's super readily available, that can be fragmented easily, something that's a little bit rare, and something that might be impacted by wild closures. And you need to know where they're found in the wild. So are these corals coming from Indonesia? Are they coming from northern Australia? Can they be found in both places? Because ultimately you're going to need to pick a place on the planet to make your tank mimic. So if you know that coral came from the northern portion of the Great Barrier Reef, you're going to need to pick Cairns or some other town there to mimic your sunrise and sunset and moon phases. And hopefully you know a little bit of information about when that coral spawns in the wild. And this, you really have to dig into the scientific literature a little bit. If you at least know it spawns in November, that's a good place to start. Some species, we know nothing. That's a lot harder. Probably don't start with that one. Start with one that we at least know, okay, it spawns after the full moon of November, maybe on the 3rd to 5th night after the full moon of November, so you know when to be watching your tank. For us, we knew what we wanted to work with because we're working with all of the corals in Florida that are dying rapidly from stony coral tissue loss disease. So for us, the broodstock really was driven by this event that started in 2014 and has spread throughout Florida's coral reef by 2021. It's a very deadly disease, affects 22 different species of coral, and certain species have been lost up to 94% across their range just because of this disease. The most heavily impacted is the Atlantic pillar coral. This is some very early pictures of when I started at the Florida Aquarium. This was the first species we were working with, and they actually came from actively diseased locations. So they came in with stony coral tissue loss disease. Picture on the right is like the very beginnings of that disease on a coral. So we had to learn how to stabilize these corals and treat this disease. And ultimately in the wild, as I said with pillar coral, this disease really took a toll. There's only 24 genetic individuals, 4 of those are diseased, and the other 20 are less than 5% of their original size. So this species is considered functionally extinct in the state of Florida. What does that mean? There's still a few alive, however, they have no hope of reproducing with one another in the wild. So they cannot actually recover without human intervention. They are separate, male and female, and the male, who might still only be this big, and the female, maybe that big, is like 5 miles away. So when they release their eggs and sperm into the water in August, they're never going to find each other. So that's a major reason why we started with this species in our program. I'll go a little bit about maintaining the health of the broodstock, but Sarah Stevens tomorrow is going to be talking a lot more about coral health in aquariums, and I highly suggest you go to her talk. One of the things with pillar coral is we actually worked with a local pharmaceutical company and a pharmaceutical formulator to develop a topical amoxicillin treatment for this disease. So the white paste line that you see on that big chunk of pillar coral actually is a slow release compound that releases amoxicillin into a mucous membrane over a 3-day period. And it's highly, highly effective at stopping stony coral tissue loss disease. It's so effective that the people we worked with to develop this formed their own nonprofit, and they're now selling it and donating it to Caribbean islands around the Caribbean, and they're using this in the wild. This has been applied to over 12,000 corals in the ocean in the state of Florida, and countless more throughout the Caribbean. And it does actually stop the progression of that disease. So there are tens of thousands of corals that have actually been saved by this treatment that, again, was really driven by keeping corals in an aquarium. The #1 way to do this right now is using an apex. And pretty much any lights that can be controlled by the apex, you can make this work. And ideally, you also want your temperature swing to be controlled by the apex, but it's not 100% necessary. You can manually change the temperature for the season. But you really want this apex to be controlling the sunrise and sunset and the moonrise and moonset. So here's an example of the season table. It's hard to see on this slide, but this is where you need to pick your point on the planet that you're trying to mimic, because you have to go on the computer, timeanddate.com, and put in whatever city, like Cairns, Australia, and find out the sunrise and sunset on the first day of the month, every month for that year, and the moonrise and moonset on the date of the new moon for every month for that year. And you just enter that in the season table, and then you need to know your temperature swing over the course of the year. This can be a little tricky. One thing we've used is looking at dive shops and what they say, oh, the temperature is this in this month, and the temperature is that in that month, if you can't find any really good scientific data that's actually taken underwater on a reef that you're trying to mimic. We've actually found the temperature swing is maybe not entirely critical. Jamie has messed with this, we've messed with this and trying to keep it flat the whole year. And it might shift the month of spawning a bit, but the corals do usually spawn, even if the temperature is kept flat. So insider secret there. And with this season table, one thing you have to do manually is change the intensity of light. So if you're not on the equator, the sun actually will be more intense during the summer and less intense during the winter. So you have to go in and change the overall output of, we use radions. They might be at 90% output in August in the peak, and then on like the December 21st, which is the winter solstice, they're probably at like 60%. So changing that percentage based on the amount of irradiance that you're getting. There's a lot more information about this. Jamie has talked about this. Richard Ross has talked about this. There are publications, so I'm not going to get into the details. You can go to Jamie's paper. They're both in my paper. They're both publicly accessible. don't focus so much on what's written in the paper, go to the supplemental information. The supplemental information literally has screenshots of our season tables and the programming in the apex. And then after you've done all that, it's sit and wait. This is the maize coral. This one is actually also very heavily impacted by stony coral tissue loss disease. This one's really nice because they spawn before sunset, so they make really great videos. This is the grooved brain coral, and this is real time. This is not sped up, and we'll have 12 colonies in one tank, and they will all do this within 10 minutes of each other on the same day every year, like clockwork. And these guys produce tons and tons of offspring. So to put this in perspective, from those 12 brain coral colonies, we're able to produce 2 million larvae from a single spawning event. So if you could actually settle and raise 2 million larvae, you have the potential to produce tens of thousands, even hundreds of thousands of offspring from just 12 parent corals. This one's my personal favorite because it is the most difficult. This is the Caribbean elkhorn coral. This one's tricky. This one, despite being in the tanks for 4 years now, still only about 20 or 30% of the corals will spawn. So we're missing something with these. It's the only one that doesn't work perfectly, and I have no idea why. So we're playing with this. Is it nutrition? Something's not quite right. But after this summer's bleaching event, this one is really, really critical to figure out because we lost probably another 80% of our living elkhorn coral on Florida's coral reef just in the past couple months. Now what? You did all that, now you have to make larvae. So a lot of what you're seeing in those videos is a bundle of sperm and eggs that rises to the surface, or it could be eggs and sperm released separately in the water. Got to collect all that out of the aquarium. If we have just a little bit, we'll use one of those gravy separators you see at the bottom. A medium amount will be a bowl, and if there's a lot, that just goes into a cooler. And those egg and sperm bundles start to break apart, and that sperm becomes very, very concentrated. Imagine this is supposed to be happening out in the ocean, so it gets diluted very, very quickly. But when you're containing it in a cooler, it can very quickly actually use all the oxygen in that water, and you need to dilute that sperm and give it nice, clean, filtered, aerated seawater and get it down to a pretty low concentration, just barely cloudy. And then fertilization will generally start to occur within the first hour. And this is what fertilization looks like. Start with the egg, and then we'll check under the microscope, and eventually you start to see what we call the butt stage, which is 2 cells, and then 4 cells, 8 cells, etc., until it turns into a swimming planula larvae. That could be 24 hours for some species. For some species, it's 5 days. Everyone is a little bit different. These are very fragile. In the early stages, you don't want to be shaking them a lot. You don't want to be pouring them from one container to another because those cells can shear apart, and then that ruins your larvae. Ideally, you end up with a nice clean batch of larvae that looks like this. This is the Atlantic pillar coral. These guys are pretty small. They're only about 500 microns. And then these larvae need access to their symbiont, or their zooxanthellae that lives in their tissues. There's a couple ways you can do this. You can settle them in an aquarium that has the same adult corals living in it, because they're constantly shedding those symbionts out into the water. Those symbionts can live free living in substrates. You can season your settlement tiles in a tank with adults. But the actually interesting thing about doing this for the hobby is you can now buy zooxanthellae in a bottle. So for a lot of these Indo-Pacific species, I would be just buying them zooxanthellae in a bottle and dumping that in there and hoping that they're taking it up. I can't do that with corals from Florida because I don't have clean, known, sourced like symbiont cultures that came from Florida, because if I used a symbiont from the Indo-Pacific, I'd never be allowed to put that coral back out on Florida's reef. But if you're doing this for the hobby, you can use pretty much any symbiont source that you like. And when you go to settle the corals, they really like crustose coral and algae, that nice pink stuff that grows in a happy reef aquarium. And that picture on the top right probably has 150 coral settlers on it. They really liked that tile for some reason. And there might be one on another tile. They tend to aggregate and then not like another one. So you just give them a lot of different substrates and they'll find a spot that they want to settle. We use these very simple dish pans from the dollar store. You can see in the top left, they've got a hole drilled in the side with 150 micron mesh. We just toss the settlement tiles in there, pour the larvae in there. They have a little trickle of water running through them. Give them about 5 days to find where they want to settle, and then you can pull those tiles out and put them into a growing tank. And this is what they look like about 3 or 4 months later. As you can see, some of them are big clusters that have had high survival on that tile. And that's a problem because they'll start to compete with each other and they keep each other really small. The big thing we have to think about is how do we get these things to grow as fast as possible. So we actually go through and cut all of those up at that point and put one on every individual plug or tile. And once you do that, they start to grow a lot faster. I just had to include this because this is our first batch of pillar coral babies. So there's been no recorded actual recruitment of a new pillar coral offspring since 1960 in the state of Florida, and we now have 120 new ones at the Florida Aquarium that we're very proud of. They have not been used for restoration yet because this species is so sensitive to stony coral tissue loss disease, but one day they'll get out there. There's a little bit older one in the top left, that tag on there that says DSIL 20, that tells me it's Dendrogyrus cylindrus, which is the Atlantic pillar coral, and 20 means this is a larval batch from 2020. So all of our corals are tracked by their larval batch, so we know how old they are, and we can actually go back and look at what parents contributed to that group of offspring. And when we think about doing this for large-scale production, the coral in the center and the bottom, those are Acroporis cervicornis, those are only about 1.5 years post-settlement. So this is realistic to get growth rates that can make them to a sellable or marketable size within a year, especially for fast-growing species like the acroporids. Some of the other ones take a little bit longer, but you can do this by the thousands and grow them to a point that they would be sellable within a year or two. So these little babies are really sensitive to water quality, nutrient ratios, dissolved organic carbon, kind of everything's got to be just right. And what happens is if they're unhappy, you lose them very fast. You know, they're only 2 millimeters in diameter. So if that starts to get rapid tissue necrosis, it goes pretty quick. It can go from the morning to the afternoon and they can just be gone. They don't need a lot of light, not at first. They don't even have their symbionts at first. And then they get their symbionts and it takes a while for that relationship to settle and develop. So we keep them under really low light at first and then slowly increasing that over the next 3 or 4 months. Targeted feeding, because they don't have that stable relationship with their symbionts right away, it's important that they're getting their nitrogen and phosphorus from heterotrophy from feeding them. And then using grazers to help clean around them. They're very sensitive, it's a lot of manual labor if you're gonna sit there and scrape the algae around every single little tiny coral baby. And really to make this cost effective, you need to maximize all of those things. We can achieve as high as 50 to 60% post-settlement survival. So you imagine if I start with 10,000 larvae, I can get 50% settlement, there's 5,000 corals, and I got 50% post-settlement survival, that's 2,500 corals that actually live to a year to a potentially sellable size from only 10,000 larvae. And remember I told you that one species produces 2 million larvae every spawning event. So this is possible. Definitely need to be maximizing that growth rate. You really want them to be gone within a year, 18 months max, and out the door so you have room for the next batch. And reducing human labor through co-culture of grazers. So those are baby Lithopoma snails that were raised at our facility. Tiny snails are great around tiny corals. Tiny urchins work too, but the urchins grow faster than the coral. So tiny snails is really the best. To put it in perspective, the cost of production for a coral from our facility right now is about $68 to $150 for a full plug-sized coral. So this isn't necessarily something you want to do with a coral where an asexual fragment sells for 30 bucks, not yet. But if it's coral that sells for several $100s, this is definitely, I think, a very reasonable way to produce them. And this is being done in Australia. Just shouting out to the Interfish group, they've spawned, I think, 10 or 11 different species, and they just now have their first spawning-derived corals that are for sale for the trade in the hobby in Australia. They're not able to export them yet because they're captive bred. And there's something about the Australian export and CITES where they won't let them export captive bred things. They can export wild collected things, but not captive bred things. So they're working on that. But they also get some amazing color patterns in the juveniles. And I think this is a really, really interesting field to start researching the genetics behind what drives these color patterns that really drive the value. But a lot of people ask me, well, what does it take to do this for restoration? Not necessarily selling it for the hobby. How do I grow corals and actually be able to put them back out on the reef? Well, that comes with a lot of rules. So if you're not a rule follower, it's not for you. This is heavily managed by FWC and NOAA. We have receiving guidelines, care guidelines, data collection every month, health assessments, maintaining biosecurity. And everything in our facility has to originate from the state of Florida, the live rock, the snails, everything, because you don't want to potentially introduce any non-native species when you put those corals back out on the reef. Everything is disinfected in between systems. We do exchange between coral nurseries, but that is also heavily regulated. A little bit more about that biosecurity. So we hold corals that were never exposed to stony coral tissue loss disease, and then we hold corals that did have stony coral tissue loss disease. So the disinfection procedures between those two types of biosecurity is actually quite strict. And we always work with, even the way you go about working at the facility is you work with the pre-invasion or corals that have never been exposed to disease first thing in the morning, and then you move to the ones that potentially have been exposed to disease. Very strict hand washing and disinfection procedures. And as I said, everything must originate from Florida, the live rock, your cleanup crew. We work with a couple collectors in the Keys, so we know that even at their facility, at a wholesale facility, they haven't been put in a tank that also has things from outside of Florida. They have to be completely kept biosecure from the minute they leave the ocean to the minute they arrive at our facility. And then before they go out in the wild, they have to be certified by a veterinarian that they are healthy. So there aren't very many veterinarians that know anything about what a coral is healthy or not. There's 5 of them right now that are approved by Florida FWC. 4 of the 5 of them have actually previously worked at the Florida Aquarium or have been trained by the Florida Aquarium. But this is part of the FWC process, and it comes from releasing fish stocks back out into the wild. If you have 10,000 red snapper that you want to release into the Gulf of Mexico, what they do is they come and they sacrifice a certain percentage of those, and they look for parasites, they make sure they don't have any diseases. So they don't sacrifice the corals, but they still make the veterinarian come, ask about your disinfection procedures, look at everything at the facility, and literally pick up every one of these corals and, yep, it looks good. But then you get the very, rewarding job of getting to see something that you've grown from a larvae go back out onto the reef. And because of the overall success of this program, we've grown from just one greenhouse when I started in 2016 to soon having over 8,700 square feet. This green building is not a greenhouse. So I've made the decision to get away from the greenhouse and move into LED lighting and or metal halides. The greenhouse actually gives you exactly the spectrum that you would not want for corals. The panels of the greenhouse actually block out the majority of blue light, and it is mostly yellow, green, orange, and red. And the corals still grow and do fine. But I don't like the ability that I don't like to just be stuck with that. I'd like to be able to adjust the spectrum for different species and different conditions. So we've decided to go with a big, ugly block building that has very few windows, because basically the whole back half of that building will be controlled spawning. So we want no light pollution at all. So there's no windows, and that whole room will be on a spawning cycle to really up the number of larvae we're producing every year. And we don't do this in a vacuum. We're partnering with regulatory agencies and universities around the state of Florida and the country. And we have outstanding industry partners that, at least give us great discounts on things and have helped us even develop some of this technology over the years, and generally answer my complaining phone calls and emails when something isn't working right. For more information, check out videos on the Florida Aquariums website. Reefs.com has some great videos by Richard Back that has covered our work. Worldwide Corals came out and did a video recently, and George Mavrakis came last year to talk about our coral rescue project. Thank you for listening. If there's any questions, I'm happy to chat anything coral spawning. Yeah, it's a good question. So the question is, do we have the apex set to like shut off the pumps when we're expecting a spawning event? Because we are a public aquarium and I now have 14 employees, no, because we're there. So we've shifted the time in the spawning lab so that sunset occurs at like 1 o'clock in the afternoon. So we eat lunch, we go in there, we shut down the pumps, the lights go off, and we wait for it to happen. A lot of the species we know within half an hour. So we'll go in, shut off the pumps. But if I was doing this at home, or I didn't know exactly when that was gonna happen, I would for sure like shut off the pumps at sunset and then leave that off for as long as you could until the temperature started to shift in the tank. So we do it manually, but it certainly could be something you do in the apex. Yeah, very good question. So he asked about whether we need to do any light and nutrient acclimation returning to nature. Yes and no. Many sites, they do fine, direct from our place to the reef. If they're going very shallow, like 12 feet or less, they're obviously going to get much more intense light and some UV. So in our greenhouses, the twin wall polycarbonate blocks out all UV. There's no UV at all. So these corals have never been exposed to UV their whole lives. And we've seen in very shallow water, they do get bleaching and then they'll recover, but they do get definite light and or UV stress. So what we actually have a student, one of my employees who's working on her master's, just did a project where we did a UV acclimation period. So we just added some UV lights and then didn't UV acclimate some of them, and those just went out on the reef. So we'll be seeing what the results of that is and whether that is what's causing the bleaching or it could just be sheer intensity of light. So we do try to make sure our corals are getting pretty intense light. They're getting 600 par in the summer because they're going to be outplanted pretty shallow. And having that fuller spectrum too is helpful with that. You don't want them to have never gotten any red light in their entire life and then put them in 10 feet of water. So yes, but no. If they're 20 feet or deeper, they seem to acclimate just fine. Nutrients is an interesting one though too, because we in our tanks will try to keep nutrients very, very low. Detectable but low, and it's a fine balance. But like a lot of reef tanks run perfectly fine with a phosphate of 0.1, 0.2 and nitrate of 5 to 10, but I don't want the corals to be adapted to that because then when they go back out on the reef, there's not going to be that nutrients. Yeah. Yeah. Yeah, well the calcification rate really for us, it depends. We can drive it up mostly with the par and feeding. Yeah, so getting them up to whatever the highest par they can really tolerate and feeding is really how we're driving the growth rate as much as possible. And some species are just never going to, be super fast growers. Yeah. Right now, it is. There's a couple other manufacturers. Well, it's not true. So there is something called the insulation table in Mobius. You have to ask them to activate it for you. And that you actually can upload 365 days of data in a CSV file, and it will do the sunrise and sunset and the moonrise and moonset with the newer radions through that insulation table. I will admit it's still very buggy because it was pretty much developed just for us to try to make corals spawn with the Gen G5s and the G6s, but we're still tweaking. But it's not entirely impossible to just do it with timers, especially if you're mimicking somewhere that's close to the equator. The sunrise and sunset doesn't change all that much. So it is, if you're really dead and you're there at your house and just change it every week, it's still possible. Yeah, that's a good question. So where did the disease come from? I wish we all knew. The disease started in Miami area, and it started shortly after the Port of Miami dredging project. There's no proof that it actually came from that, but they coincided. And there has been a lot of research into trying to identify the pathogen in that disease, and there's still no definitive answer. The closest we've gotten is potentially it's a virus that impacts the algae in the tissues, but it's still, we wish we all knew. And it unfortunately has spread throughout the Caribbean as well. So things like the Atlantic pillar coral is now been proposed to be bumped up to endangered classification on the endangered species list. So it was listed as threatened, but now because it's being lost 90+% throughout its entire range in the Caribbean, it's very likely that that's going to be bumped up to endangered very, very quickly. But the good news is we have 160 different genetic individuals at our facility, and we can breed them. So the day the ocean can take them back again, we have the ability to do it. That's the big money question. If I could answer that question, I probably would be living in a mansion in the mountains somewhere. The question was, when will that happen? When will the ocean be ready to take them? I hope that, as a society, we begin to care about our planet more than we do now. But that's a bit out of my personal power. I think it can be improved in 50. And we're also looking at things like selective breeding of corals. The spawning work opens a lot of doors. It's the selective breeding to make designer corals for the hobby, but it can also be the selective breeding to try to make a coral that lives in 95-degree water. Or even the algae that lives in their tissues, I think is really promising work there, that if you can have that algae be heat tolerant, then it doesn't leave in a bleaching event. So it may not be that the ocean is totally better yet, but we might be able to meet it halfway by making stronger corals. And there is something to be said for the diversity of the new generation. We take 12 parents and produce 5,000 different genetic combinations. So then we monitor them. So we'll be going out in the next couple weeks to look at a bunch of juvenile brain corals that we've been told from people in the Keys didn't bleach this summer and look great. So there's something to be said for this new combinations of genes and just helping evolution along by producing new offspring and then figuring out which ones are doing well, and maybe they become the parents for the next generation. So that's really why we focus on the spawning side of this work rather than just asexually propagating. Yeah. Ooh, what are we feeding and how often? We feed a lot of reefroids, we feed frozen copepods, we feed reef chili. We can't feed anything that has probiotics in it, so that's a sticking point, because if we don't know that bacteria culture originated from Florida, then they won't be able to go back out onto the reef. We feed a lot of frozen foods, frozen copepods, frozen mysids. We feed TDO, Chroma Boost, pellets, and golden pearls. The babies, their diet is reefroids, and the tiny golden pearls is their primary diet. Oh. Yeah. So the question is, are we studying any of the ones we put back out to see if they start spawning? We haven't actually done it with any of the ones that we personally have put out, but we provide corals to 7 different restoration practitioners and researchers in the state of Florida. So they have come back to us and said, yes, the corals you gave us in 2019 spawned last year, actually. So it takes 3 to 5 years from the time they settle as a larvae to become sexually mature and spawn, which is actually shorter than many people think. So it's a good question. We try to avoid it for now because there's a limited parent pool in those offspring. So you are at risk if you're then crossing a bunch of what could potentially be half and full siblings, then that might not be good for the population. So until we have many different batches from many different parents is when we will start focusing on the settlement of like an F2 generation. Got it. We get settlement of some species, but the acroporids, the staghorn and elkhorn, there hasn't been a confirmed documented sexual recruit on Florida's coral reef for decades. And it's likely that the larvae that settle in Florida actually come from somewhere else, because they drift in the plankton for 5 days. So for the acroporids, they're probably coming from Cuba, maybe Puerto Rico. So our larvae probably go to the Bahamas. Cool. Thanks, everybody.